Welcome to the lesson on working with algebraic expressions and equations. In this lesson, we will discuss some of the basic operations and basic techniques that we can use in order to help us understand algebra. By definition, we know that algebra consists of terms, and we can simplify and substitute these terms to ultimately help us find the solution that we are looking for. But let's think about exactly what a term might be. Well, in algebra, a term could be anything as simple as x, that unknown quantity that we don't know. 5x is also a term, where 5 times x is represented in shorthand, 5x. 7 is also a term. A term like 7 is known as a constant. And 2x squared is a term, where 2x times 2x is represented by a 2x squared. All these things are terms. But in some expressions where I have lots of terms, what do I do to simplify the scenario? Well, I can combine by adding or subtracting like terms. Like terms are those that are of the same variable and of the same power too. So let's take a look at a pretty complex algebraic expression where I have x squared plus 2 plus 3y plus 4x plus 2x squared plus 5y plus 10. 7 terms, and I know I can combine some. I can combine the x squared plus the 2x squared. I can combine the 3y and the 5y, and I can also combine the regular 2 with the 10 at the end. Now the 4x, because it doesn't have any like terms with it, stays in the middle and nothing necessarily happens to it. At the end of the day, after combining, I have 3x squared plus 8y plus 4x plus 12. By combining these like terms, I can shorten down very long algebraic expressions and then work towards solving equations. Let's look at one where we can simplify and combine like terms to help us solve an equation. 2x minus 4 equals 5x minus 12 minus x. In this case, I can combine like terms on one side of the equation and then combine them across the equation as well. So 5x minus the x will give me 4x minus 12 on one side, with the 2x minus 4 on the other side still intact. Now I can work towards combining like terms across the equal sign. So I'm going to take the 2x from one side and subtract it on both sides. I'm going to take the minus 12 and add 12 to both sides. In this way, I can cancel out things on both sides of the equations, leaving me with a 4x minus 2x, giving me 2x on one side, and a minus 4 plus 12, giving me a positive 8 on the other. In this case, then, I can divide by 2 on both sides to finally give me the x, or the 1x, equals 4. Now, although we were careful, how can we make sure that we have the correct solution? How do we make sure that, indeed, x equals 4? Well, I can take this x equals 4 and I can go back to the original equation and substitute it in everywhere I see x. So 2 times 4 minus 4 will equal 5 times 4 minus 12 minus 4. Everywhere I had an x, I now replace it with 4. So let's evaluate. 2 times 4 is 8 minus 4 equals 5 times 4 is 20 minus 12 minus 4. Well, 8 minus 4 will give us 4 on one side, 20 minus 12 will give us 8 minus 4 on the other, and ultimately 4 equals 4. If this is true, we yield a true solution. 4 was indeed the correct answer. As we keep working and simplifying, we now look at equations with two variables that each have their own unique value that both fit in order to make the equation true. Looking at some examples, let's figure out y equals 2x minus 5 if x were 8. So with the value of x known, what is the value of y? Let's plug 8 in wherever we see an x. So 2 times 8 is 16, minus that 5. 16 minus 5 gives me 11. So in this case, when x is 8, y equals 11. Look at my next example. Let's solve this expression if x is 2 and y is 8. So let's substitute in everywhere we see a y or an x. 2 times 8 plus a 2 for the x minus the 10. So 2 times 8 will give me 16 plus 2 and then minus 10. So 16 plus 2 is 18 minus 10 will ultimately give me a final answer of 8. I plugged in the values and I found the solution. So now we think, is 10y equal to 2x plus 15 true if y equals 5 and x equals 10? Well, 10, insert the 5, equals 2, insert a 10, plus 15. Now that I've inputted the values, let's solve. 10 times 5 is going to be 50. 2 times 10 is going to be 20, plus 15. If I add the 20 and the 15, I get 35. Set that equal to 50. And it doesn't take much to realize that that is not true. So that equation is not true if the x and the y have those values. So connection as we continue with algebra continues to be strong, and finding the cost of the items or finding the rate of change is just a few of the simple examples that algebra can have in our real world.